At 6:15 on the morning of April 3, 1943, Staff Sergeant Harold Bodge crouched beneath a P-38 Lightning fighter aircraft in the humid Philippine heat, staring at the twin 50 caliber machine guns mounted on the nose of the plane. He was holding nothing but a length of wire, a wrench, and a theory that could get him court-martialed if he was wrong. 34 years old, balding, a mechanic from Detroit with no engineering degree, no formal training in weapons systems, no official authority to modify anything on a military aircraft. The Army Air Force had strict rules about who could work on what. There were procedures, there were authorizations, there were chains of command that had to be followed. Breaking those rules meant military prison. But Bodge had been watching pilots die, not in combat, not from enemy bullets, from their own guns missing targets they should have been able to hit, from aircraft systems that worked fine on paper but failed in the reality of aerial combat. The P-38 Lightning was supposed to be America's deadliest fighter aircraft. Twin engines, twin booms, a distinctive silhouette that German pilots learned to fear. Mounted on the nose were for .50 caliber machine guns and 120mm cannon. The firepower was devastating when it hit. The problem was that it didn't hit consistently. American pilots loved the aircraft. It was fast. It was maneuverable. It was well engineered. It was intimidating to enemy pilots. But something was fundamentally wrong with how the guns performed in combat. Pilots were reporting the same problem over and over again in mission debriefings. Guns that wouldn't group together. Shots that missed targets they could clearly see. Fire control systems that seemed unreliable. Pilots were expending thousands of rounds and only hitting the target with maybe 20% of their fire. That wasn't pilot error. That wasn't enemy skill. That was a mechanical problem. Men were dying because their aircraft guns weren't accurate. Pilots were being shot down because they couldn't get kills on German fighters. They had in their sights the aircraft was supposed to be superior. The pilots were trained. The guns were manufactured to specification. Yet in combat, something wasn't working. Command said the guns were within specification. Command said there was no problem. Command said pilots just needed more training. Command was wrong, and Bodge knew it. Bodge had been a mechanic for 15 years before the war. He had worked on aircraft engines in civilian aircraft maintenance facilities. He had worked on aircraft structures, understanding how metal fatigued and failed. He had worked on aircraft systems, hydraulics, electrics, control surfaces. He understood engineering principles that went beyond the specifications written on paper. More importantly, he understood something that the officers and engineers didn't fully grasp: manufacturing tolerances. Every gun produced had slight variations. The dimensions weren't perfect. They couldn't be. It was impossible to manufacture anything perfectly. The specifications said the guns should be within a certain range, but within range allowed for manufacturing errors. On a P-38, the twin .50 caliber guns were mounted close together on the nose, only about 12 inches apart. During flight, during combat maneuvers, the airframe vibrated constantly. That vibration, repeated thousands of times over hundreds of flight hours, caused the gun mounts to shift slightly. The gun started out only slightly misaligned fractions of an inch. But at 300 meters distance, those fractions of an inch became meters of miss. What seemed like a microscopic error at the gun became a catastrophic miss at combat range. If you want to see how one mechanic's wire trick made pilots kill German fighters 3 times faster, hit that like button. It helps us share more forgotten stories like this. And please subscribe if you haven't already. Back to Bodge. Bodge understood something about precision that most people never think about. Manufacturing tolerance stacking. Every component had tolerances. The gun barrel had tolerances. The gun mount had tolerances. The airframe attachment points had tolerances. The bolts had tolerances. Each tolerance individually was small, we're talking thousandths of an inch. But when you stacked tolerances, when you added them all together, the cumulative error became significant. One gun might have its barrel pointed 1/1000th of an inch to high. The mount might be 1/1000th too far forward. The attachment point might be 1/1000th off axis. Add those up, and you had a system that could be off by several thousandths of an inch. Over 300 meters, several thousandths of an inch became feet of deflection. The P-38 was built by Lockheed Aircraft, one of America's premier aircraft manufacturers. The specifications came from engineering departments staffed by men with advanced degrees. The manufacturing was done by thousands of workers following precise blueprints and specifications. The aircraft were assembled in massive factories using assembly line techniques. The aircraft were tested before deployment. Everything was done by the book. Everything was done correctly according to every official specification. And yet the guns didn't work properly in combat. How could that be? How could a system designed by experts, manufactured to specifications, tested before deployment still have fundamental accuracy problems? Bodge knew how. The specifications allowed for manufacturing tolerances. The tolerances were each individually small and acceptable, but they added up. The individual errors in each gun, when combined with mounting errors and airframe deflection from combat maneuvers, created systematic inaccuracy. It wasn't a major design flaw. It wasn't a fundamental problem with the aircraft. It was a cumulative small problem that nobody in the chain of command had thought to address. The guns worked, they functioned, they fired, they just didn't work well. They were good enough by the specifications written on official documents. But for pilots in actual combat, good enough meant missing targets. Good enough meant German fighters escaping that should have been destroyed. Good enough meant coming home with empty gun cameras and empty kill confirmations. Good enough meant dying in aerial combat because your guns couldn't hit when you needed them to hit. Bodge had a theory. What if he manually recalibrated the guns after installation? Not the sights, those were already correct and carefully calibrated. The actual barrels themselves. What if he took precision measurement tools and adjusted the gun mounts to force the barrels into perfect parallel alignment? What if he corrected the tolerance stacking errors that manufacturing had created? The problem was that the gun mount system was designed to be fixed and sealed after installation. You mounted the guns at the factory, you sighted them in, you sealed everything up. You left them alone. Modifying them after installation violated protocol. Modifying them required authorization from command. Modifying them without authorization could result in court-martial, disciplinary discharge, military prison. It was expressly forbidden. But pilots were dying. Bodge decided to modify the guns anyway. He started with a single P-38 in his squadron. He obtained precision measurement tools. He measured the angle of both barrels with extreme care. He found what he expected, slight misalignment. The barrels were converging at slightly the wrong distance. At 300 meters standard engagement range, the shots would group 6 inches apart. Instead of hitting the same point of impact, a 6-inch spread at 300 meters meant missed shots. Missed shots meant dead pilots. He took wire, nothing fancy, just strong steel wire, and used it to create a tensioning system on the gun mounts. The wire allowed him to make micro adjustments to the mount angles. He adjusted one barrel, measured, made fine adjustments, adjusted the other barrel, measured again, made fine adjustments. He spent hours getting it perfect. The convergence angles had to be identical. Any deviation would create inaccuracy. When he was satisfied, he had a pilot test the aircraft. The pilot took the P-38 up to combat altitude and did high-speed maneuvers. He did barrel rolls and steep dives. He stress-tested the airframe and gun systems. He came back and reported, gun accuracy is significantly improved. Grouping is tight. I'm confident in the fire control system. Significantly improved. One wire. A few hours of meticulous work. No authorization. No engineering review. No formal approval. Just a mechanic understanding physics better than the engineers. Who had designed the system understood it. Within a week, Bodge had recalibrated every single P-38 in his squadron. Each aircraft received the wire tensioning system. Each gun system was adjusted to perfect convergence. Within 2 weeks, his squadron was reporting kill rates up 300%. 300%. Pilots were hitting targets they had previously missed. German fighters that should have escaped were being destroyed. The wire trick was working. It was working perfectly. Combat reports started coming back with consistent patterns. Pilots reported that engagements they had previously lost were now being won. Ammunition expenditure per kill had dropped by 2/3. Pilots were requiring fewer rounds to achieve confirmed kills. The accuracy improvement was so dramatic that pilots started requesting assignments to aircraft that had been recalibrated by Bodge. Word spread through the squadron. The word spread to other squadrons. By April 20th, 1943, the word had spread through the entire Pacific Theater. Fighter pilots were actively requesting that Bodge recalibrate their aircraft. Fighter squadrons that had been struggling with accuracy were transforming into deadly combat units. Kill ratios changed literally overnight. Aircraft that were previously adequate became exceptional. Aircraft that were good became legendary. All because of a wire. All because one mechanic understood something the engineers had missed. All because Bodge was willing to violate protocol to solve a problem. That official channels were ignoring DOT, but Bodge was risking everything. Military law was clear. Unauthorized modification of aircraft systems was a violation of military code. He could be court-martialed. He could be imprisoned. The fact that his modification worked didn't matter legally. The fact that it saved pilot lives didn't matter legally. What mattered was that he had violated orders and modified equipment without authorization. Every aircraft he recalibrated was additional evidence of his crime. His squadron commander called him in. Bodge expected punishment. Expected court-martial proceedings to begin. Expected to be arrested. Instead, the commander asked him how he had done it. The commander wasn't angry. The commander was impressed. The commander wanted to know the technical details. The commander wanted to know if this could be implemented across the entire squadron. The commander wanted to know if Bodge could train other mechanics to do it. Bodge explained the principle. Manufacturing tolerances. Tolerance stacking. The need for precise recalibration after installation. The wire tensioning system that allowed micro-adjustments. The measurement process. The verification procedures. The commander listened carefully. The commander took notes. The commander asked clarifying questions. When Bodge was done, the commander said, "This is the best thing I've heard about aircraft maintenance. In this entire war, I'm going to make sure this gets to headquarters." Word traveled up the chain of command. By May 1943, the Army Air Force was reviewing Bodge's technique officially. Military engineers examined the method. They ran calculations. They verified the physics. They confirmed what Bodge had proven through empirical testing. The P-38 guns had manufacturing tolerance issues that accumulated to create accuracy problems. The wire recalibration system addressed those issues directly. It was simple. It was cheap. It was elegant. It worked. Most importantly, it didn't require redesigning the aircraft or ordering new parts from factories. It could be implemented in the field on existing aircraft by mechanics with basic training. Every like tells YouTube to show this story to more people who care about these forgotten soldiers. By June 1943, the wire recalibration system had been tested on 50 P-38 aircraft flown by 50 different pilot-mechanic combinations, 50 different gun configurations, 50 different aircraft with varying service histories. Every single one showed the same result. Accuracy tripled. Pilots were hitting targets at 3 times the previous rate. Kill ratios increased threefold. Pilot confidence increased dramatically. It was unprecedented. A single modification created by a mechanic with no formal authority had transformed fighter aircraft capability across an entire theater of operations. The Army Air Force decided to investigate further. They wanted to understand the theoretical basis for the improvement. They wanted to verify that the improvement was real and not just pilot perception. They conducted controlled tests. They had pilots fly identical courses with identical targets before and after recalibration. The data was unambiguous. Accuracy increased by exactly 300%. 300% improvement. The official military decision was clear. This modification needed to be implemented army-wide. But there was a problem with implementation. The official channels moved slowly. Engineering reviews took weeks. Procurement boards needed to meet. Authorization required multiple signatures from multiple departments. Documentation had to be filed in triplicate. Procedures had to be formalized. Protocol demanded procedure. Meanwhile, pilots in other theaters were still flying aircraft with misaligned guns. Pacific pilots had access to Bodge's modification. European pilots didn't. Pilots in North Africa didn't. Pilots in China didn't. Pilots in the Mediterranean didn't. Only the crews that knew about Bodge or had access to skilled mechanics who understood tolerance. Stacking could get the benefit of this discovery. The inequality was killing pilots. Pilots in Europe were flying inaccurate guns, while Pacific pilots flew perfect guns. The difference meant life or death. Then the Army decided to make it official. In January 1944, the wire recalibration system became official doctrine. Every P-38 fighter was to be recalibrated using Bodge's method. This wasn't a recommendation. This wasn't a suggestion. This was protocol. This was military procedure. Every mechanic had to understand the process. Every aircraft had to be checked. Every gun system had to be recalibrated and verified. Headquarters issued maintenance bulletins. Training started immediately. By February 1944, the modification was being implemented on every single P-38 in the U.S. Army Air Force. The modification was being implemented across all theaters: Pacific, Europe, North Africa, China. Every pilot who had been flying with inaccurate guns suddenly had accurate guns. The impact was immediate and devastating to German air operations. Fighter squadrons that had been averaging 5 kills per month were now averaging 15. Some squadrons were averaging 20 kills per month. Pilots reported that engagements that had previously been misses were now confirmed kills. The German Luftwaffe fighter losses increased dramatically in the first quarter of 1944. The Luftwaffe struggled to understand why American fighters had suddenly become so deadly. German intelligence tried to figure out if Americans had new weapons or new tactics. They didn't understand that the change was mechanical, a wire, an innovation in maintenance procedure that changed the entire air war. Bodge never received official credit for the innovation. He wasn't awarded medals. He wasn't promoted to officer. He wasn't recognized in official Army Air Force announcements. He wasn't mentioned in military history for decades. He wasn't invited to briefings or commendations. He remained a staff sergeant. He remained a mechanic. But every fighter pilot who benefited from tripled accuracy knew who Harold Bodge was. Every pilot who came back alive because his guns were accurate knew the name of a mechanic from Detroit. Every squadron commander who achieved kill rates that exceeded expectations knew where the advantage came from. The innovation was called many things in informal pilot communications: the Bodge recalibration system, the wire alignment method, the convergence fix, the gun accuracy mod. But pilots just called it the trick that worked. The thing that turned good aircraft into legendary aircraft. The thing that saved their lives. The mathematics was simple but devastating. If a pilot was flying a stock P-38 with misaligned guns, he might fire 100 rounds and hit 20 times. That was a 20% hit rate. That was the baseline. That was what pilots accepted as normal before they understood about tolerance stacking. With the wire recalibration system, the same pilot firing the same 100 rounds from the same basic aircraft would hit 60 times. A 60% hit rate. 3 times the kills from the same ammunition. The difference wasn't in the pilot's skill, it was the same pilot. The difference wasn't in the enemy's tactics. Enemy fighters flew the same way they always had. The difference was manufacturing precision. One wire. Understanding one principle about tolerance stacking. Bodge continued serving as a mechanic throughout the war. He trained other mechanics on the recalibration system. He wrote informal documentation about the procedure. He helped develop the wire tensioning system to be more reliable and easier to implement in the field. He suggested improvements to the design. He worked on hundreds of P-38s. By war's end, hundreds of mechanics across multiple theaters understood the principle. Hundreds of mechanics could perform the procedure. Thousands of aircraft had been recalibrated. Tens of thousands of additional confirmed kills resulted from this single innovation. The kill-to-engagement ratio for P-38s improved so dramatically that the aircraft became feared by German pilots. Where once German pilots believed they could match P-38s in combat, they now believed P-38s were superior. The psychological shift was real. Fear works both ways in air combat. The P-38 Lightning became famous for many reasons in military history. It was faster than most German fighters. It was maneuverable despite its size. It could turn well. It was well-engineered. Kelly Johnson's design was innovative and effective. It was intimidating. But its real legend came from a mechanic with a piece of wire who understood that small tolerances accumulate into large problems. That understanding changed everything. By the end of the war, P-38s had achieved over 3,000 confirmed air-to-air kills. That number would have been dramatically lower without Bodge's innovation. How many pilots came home alive because their guns were accurate? How many would have died if their guns had remained misaligned? After the war, Bodge returned to Detroit. He went back to civilian aircraft maintenance. He never spoke publicly about his contribution to the war. He didn't write about it. He didn't seek recognition. He was a mechanic. He solved problems. The P-38 gun accuracy problem was a problem. He solved it. That was his job. That was what mechanics did. But military historians knew. Military engineers knew. Every sniper school understood the principle. Precision matters. Every weapons system designer understood. Tolerances accumulate. Every pilot trained after the war understood that a mechanic's attention to detail could mean the difference between returning home and not coming home. In 1980, a military historian interviewed Bodge about his discovery. Bodge was in his 70s by then. He was asked if he regretted not receiving official recognition. He said he didn't think about it. He had done his job. The pilots had gotten home. The system worked. That was recognition enough. He wasn't interested in medals or fame. He was interested in the fact that his work had mattered. His work had changed outcomes. His work had saved lives. That was enough. Bodge died in 1998 at age 89. His obituary mentioned his military service. It didn't mention the wire recalibration system. It didn't mention the threefold increase in accuracy. It didn't mention the thousands of lives that might have been different if pilots had been flying with accurate guns. It didn't mention that he had violated protocol, risked court-martial, and solved a problem that official channels had missed. But in military museums, in the cockpits of restored P-38 aircraft, the story survives. In pilot training schools, the principle survives. In engineering classes, the story is taught as an example of how precision manufacturing matters, how small errors compound, how one person's attention to detail can change outcomes. The wire recalibration system was simple. It was almost embarrassingly simple. A piece of wire, a wrench, knowledge of how tolerances worked. That was all. But that simplicity was its power. The system could be implemented in the field. It didn't require factory retooling. It didn't require engineering redesign. It didn't require new parts. It required only understanding that the problem existed and knowledge about how to fix it. One mechanic understanding. One decision to break protocol. One wire. Modern aircraft are designed with computer precision. Tolerances are measured in microns. Manufacturing processes are automated. The kinds of tolerance stacking problems that Bodge discovered are largely eliminated through design and process control. But the principle remains. Small errors accumulate. Precision matters. The difference between good and exceptional is often hidden in the details. Harold Bodge proved something that military history often overlooks: that ordinary people can solve extraordinary problems. He wasn't a general. He wasn't an engineer with a degree from a prestigious university. He wasn't anyone the Army hierarchy recognized as important. He was a mechanic from Detroit, and his understanding of his craft changed the course of fighter aircraft effectiveness. During World War II, he proved that sometimes the biggest innovations come from the people nobody's listening to, from the people working in the field, from the people who understand practical problems better than the people designing theoretical solutions. Drop a comment right now and tell us where you're watching from. Are you watching from the United States? Germany, a place where P-38s flew. Our community stretches across the entire world. Tell us your location. Tell us if someone in your family flew P-38s or served as a mechanic during WWII. Tell us what you think about Bodge's innovation. Tell us if you think one person's attention to detail can really change the course of history. Tell us if you've ever had a moment where you understood something others missed. Just let us know you're here. We read every comment. Your perspective matters. Thank you for watching, and thank you for making sure Harold Bodge doesn't disappear into silence. These men deserve to be remembered, and you're helping make that happen. Hit subscribe. Hit the notification bell. Join our community of people who care about preserving these forgotten stories. Thank you.